The climate control center of a home is called the HVAC system, and what HVAC stands for is heating, ventilating, and air conditioning. Now, a system is made up of a number of components which we can show you here. First of all, we have the unit itself. That is basically the cooling unit, or the air conditioning side of the unit, and the heating side, which is typically a gas furnace, but might actually be a heat pump. A heat pump, by the way, is basically an air conditioning system that runs in reverse. Actually extracts heat out of the outdoor air and pumps it to the inside. Then in the summer months, it reverses and turns into an air conditioning system. But what we are seeing here is at the very end of this, we have a plenum, and that happens to be the return air side, the big silver duct. And then on this side, we see that we have a plenum for the supply side, and what's in between is the actual heating and air conditioning unit itself. This system is made up of the unit that does the heating and cooling and what we call the distribution system, which is the ductwork. Now, typically we see ductwork of two basic types. We see metal ductwork, which we call rigid ductwork, and then we also have flexible ductwork. Here what we're seeing are flex ducts, and basically what it is, it's kind of like a slinky. It's a helical spring-like wire that creates the ductwork, and then it has a plastic liner over that, and then we have our insulation, and then on top of that we have our reinforced foil. Now the metallized material or over this insulation actually helps reject heat too. It reflects heat so the ducts don't absorb so much heat up in a hot attic. Now, in addition to the ductwork, our distribution system also has what we call boots or metal boxes that the registers will be attached to. So essentially what happens is the heated or cooled air goes through this distribution system, through this insulated ductwork, and then terminates at these metal boxes. Now, codes often require very specific requirements around how these ducts are attached to the boots. Typically what we want to do is to use a drawband and fasten the actual inner liner of the duct to this metal boot, and then we might actually seal that with a UL 181 BFX tape or use a mastic sealant. Some codes actually require that ducts be sealed to no more than 5 or 6% of fan flow. So what that basically means is if we have a 1,200 cubic feet per minute blower system in this, we couldn't have any more than 72 CFM of duct leakage. CFM stands for cubic feet of air per minute. Now, the way these systems typically work is that we have a thermostat which controls the system. When the house calls for heat or cooling, it sends a low voltage signal to this unit and it turns on the air conditioning system or the heating system. Now, the air conditioning system is made up of two components. We have an indoor coil, which we call the evaporative coil, which is in this device here, and then we also have an outdoor unit called a compressor. And basically what that compressor does, it rejects the heat from inside the home to the outside. So the outdoor coil tends to be a very warm coil, the indoor coil is cool, and that's how we get our air conditioning. The terms that we use to rate the efficiency of a heating and cooling system are as follows. Typically we rate the air conditioning systems as its SEER. S-E-E-R, its seasonal energy efficiency ratio. And the minimum SEER, a piece of equipment that you can put in a home today, is a SEER 13. So for example, if you had a SEER 6 in a home that was say 20, 25 years old, and you went to a SEER 12, it would be double the efficiency or cut your air conditioning costs in half, for example. Now, furnaces are rated in efficiency by what they call the annual fuel utilization efficiency, AFUE. A typical older furnace may have an efficiency of about 65%. That means that about 35 cents out of every dollar that you spend on your heating cost goes up the flue. Some of the newer furnaces are anywhere between 80 and 96% efficient. So in a 96% efficient furnace, or what we call a condensing furnace, it's so efficient that only 4 cents out of every dollar goes up the flue. So when we purchase equipment, we want to make sure that we purchase the equipment that's most efficient that we can afford. Another consideration to the efficiency of equipment is how that equipment's installed, because that can have a big impact on the building envelope. We know that we have supply ducts in homes and have return air ducts in homes, but it's important that we recognize that these systems be balanced and that we don't have a lot of duct leaks, because these duct leaks can cause pressure differentials across the building envelope that cause either air to infiltrate in or exfiltrate out. And if that air contains moisture, it can condense on cold surfaces and cause lots of problems. Typically what we'll see in a home is maybe 1 or 2 return air ducts, but it's also important to recognize that we need to have an efficient pathway for air to flow in and out of rooms. So for example, if we don't have a return air duct in, say, a master bedroom, it might not cool too well, and it might actually cause fireplaces to backdraft because of these pressure imbalances. The typical fireplaces that we see in homes today are what we call zero clearance fireplaces, and basically what that means is that it's a prefabricated unit that can be placed very close to framing members without worrying about a fire. The older fireplaces obviously were masonry and they were built on site. This fireplace is basically a gas log, and of course the combustion byproducts go up through this flue, and we call this a B vent. This is a 6-inch type B gas vent, and it's designed for gas fireplaces, not for wood burning fireplaces. It gets its combustion air from the outside. That's what this metal duct is that runs from the outdoors into the fireplace, and the purpose behind that is so that to get the combustion air needed for this fire to burn, you don't want to draw that from inside the home because that creates a draft, and that's why oftentimes codes require that these have combustion air from the outside. Also, you'll notice the yellow piping. That's a stainless steel flexible gas line, and as we go up there we can see that it's connected to a more rigid metal pipe for a gas line. Now there's another type of fireplace that they use in homes which are called direct vent fireplaces, and what that basically means, it's a sealed combustion unit. The doors do not open on that like they do on this one, and the flue and the combustion air can be directly vented to the outdoors, so you don't need to have a very tall flue like you would in a fireplace like this. Now if we look over here at some of this mechanicals, what we're seeing here is an air conditioning line set, and basically what that means is that this is the piping that pipes the refrigerant from the evaporative coil, the cooling coil upstairs, out to the condensing unit. And what we have is this insulation over what we call the suction line, and then this is what we call the liquid line. Again, just a pathway to get the refrigerant from the indoor unit to the outdoor unit. So in summary, an HVAC system consists of the following. We have a distribution system which has our supply and return air ducts, our boots and our registers. We have an outdoor unit which is essentially a condensing coil and compressor. Indoors we have our furnace and our evaporative coil or our cooling coil, and all this is controlled by the thermostat, which helps make us all comfortable.